So let's talk about one of the most fundamental forces in the entire universe. It's this incredible force that's completely invisible, yet it literally rules how our entire modern world operates.
I mean, really. You can't see it, you can't smell it, you can't hear it. It's just this silent, invisible presence that fills all the space around us, right now. But you've absolutely felt it. You know that little tingle of static electricity when you take off a sweater? Or that tiny zap from a doorknob? Yeah, that's it. That's the electric field making its presence known. And this force scales up way, way up. It's the very same thing that unleashes the awesome power of a lightning bolt. And at the same time, it's the quiet magic that makes the screen you're watching this on right now even possible. So that leads to the big question, right? What in the world is this thing? How can apparently empty space reach out and push or pull on actual objects? Well, that's exactly what we're going to break down.
To really get a handle on the electric field, you have to start at the source. And it all begins with a super fundamental property of matter, something we call electric charge.
Turns out, in this whole universe, there are only two kinds of charge. We keep it simple. We call them positive and negative. And a good way to think about it is that the positive charge is the source. It's where the field starts, and the negative charge is the destination, where the field ends. And they play by a very simple, fundamental rule of nature. You've heard this one before. Opposites attract. A positive and a negative charge will always pull towards each other, but like charges, they repel. Two positives or two negatives will always push each other away. Simple, right? Well, this simple idea created a huge puzzle. For centuries, scientists were stumped by this. They called it the problem of action at a distance. It was a really big deal.
Just think about it for a second. If you have two charged particles floating in a vacuum with nothing between them, how does one know the other is there? How is that push or pull being communicated across empty space? It's not like they have tiny invisible strings connecting them.
The genius solution came from the brilliant physicist Michael Faraday. He suggested that maybe the charges aren't interacting directly. Instead, he proposed that every charge creates an invisible field of influence all around itself, and it's this field that then acts on any other charge that enters it. The field itself is the messenger. And that's the absolute key. An electric field isn't a thing in space. It's a property of space. Any charged object actually modifies the space around it, creating a region where an electric force can be felt. It's a real-life force field, just like in science fiction. And physicists have this beautiful, simple equation to describe it. F equals Q times E. All that means is the force a particle feels is just its own charge multiplied by the strength of the field right at that spot. The field literally tells the charge which way to go and how hard to push. Okay, so this field is an invisible property of space. I know, that sounds pretty abstract. So how in the world can we get a picture of what it actually looks like? Well, that's the trick. We can't see it directly, but we came up with an amazing tool to visualize it. We used something called field lines to essentially draw a map of this invisible force. Now, these are just imaginary lines, but they follow two simple rules. First, the direction they point shows which way a positive charge would get pushed. And second, how close the lines are to each other tells you how strong the field is. If they're all bunched up and dense, you've got a powerful field. And you can see that rule perfectly right here. On the left, the field lines radiate straight out from a positive charge, like sunbeams. On the right, for a negative charge, they all point inward, ending on the charge. They always flow from positive to negative. And this is where it gets really cool, because this visually shows that opposites attract rule. Look at how the field lines leave the positive charge, they curve through space, and they land right on the negative one. You can literally see the connection, the path of the force between them. And here's what happens when you have two charges that are the same. See how their field lines push away from each other? They bend and curve, but they never cross. That empty space in the middle? That's a visual representation of the repulsive force pushing them apart. So this is a pretty neat concept in physics, but why should you care? Well, because this invisible field is the engine driving almost everything in your life. That lightning strike? That's just a huge release of energy through the atmosphere's electric field. Your smartphone's touchscreen, it works by sensing how your finger disrupts a tiny grid of electric fields. Capacitors in every gadget you own store energy in an electric field. Even the thoughts in your brain are just electrical impulses, tiny disturbances traveling through the electric fields around your neurons. The Earth itself is wrapped in an electric field. It is literally everywhere.
So, the bottom line is this. Learning to understand and control the electric field is the single achievement that made our entire modern world of electricity, electronics, and instant communication possible.
And it's just a powerful reminder, isn't it, that some of the most fundamental forces that shape our reality are completely hidden from our senses. We don't see them, but they govern everything.
And that leaves us with a final thought. We've just pulled back the curtain on the electric field, but it's not the only invisible player out there. What other unseen forces, from gravity to the quantum fields that make up matter itself, are shaping your reality in this very second?